Imagine looking up at the night sky and realizing that every star you see is a ticking time bomb. Some will burn for trillions of years, steady and slow. Others will explode in a violent supernova, scattering their remains across the cosmos. And the craziest part? The very atoms in your body, your bones, your blood, even the oxygen you're breathing right now, came from a star that died billions of years ago. Stars are the ultimate recyclers of the universe. They live, evolve, and die in cycles that shape everything we know. But how does that process actually work? And what determines whether a star lives a long, quiet life or ends in a spectacular explosion? Hello, my name is Christopher Kill, armchair philosopher and your autodidactic guide to our fractal reality. Today we're going to talk about something massive, literally, stars. But we're not just talking about them as giant balls of gas in space. We're breaking them down in a way that makes sense, with analogies that bring these distant objects right into your everyday experience. Because even though stars seem far away, the rules that govern them are the same fundamental patterns that shape everything else in the universe. All right, so let's start with a question. What keeps a star from just collapsing in on itself? Think about blowing up a balloon. The air inside pushes outward, keeping it inflated, but if you let go, the outside pressure collapses it instantly. That's exactly what's happening inside a star. It's a constant battle between gravity pulling in and nuclear fusion pushing out. The balance is called hydrostatic equilibrium, and it's what keeps a star stable for most of its life. Now imagine a pressure cooker. If the heat inside builds up too much, it needs a way to release it, or it's just going to blow. That's fusion in a star. Heat and pressure in the core fuse hydrogen into helium, creating an outward force that stops gravity from taking over. Now this balance can last billions of years, but the moment fusion slows down, gravity starts winning. And here's the thing. Equilibrium isn't permanent. Stars are like engines running on fuel. And once that fuel starts running low, everything changes. Now, not all stars live the same length of time. It all comes down to mass. A small, low-mass star is like a car with a great gas mileage. It burns fuel slowly, and it lasts for billions, maybe even trillions of years. But a massive star? That's the gas-guzzling sports car burning through its tank at a high rate of speed. A small red dwarf can keep chugging along for tens of billions of years, while a massive star burns bright and fast, sometimes only lasting a few million years. Now that might seem like a long time to us, but in the grand scheme of the universe, it's like a firework compared to a candle. This is why when you look at a galaxy, you see stars at all different stages of life. Some are just forming, some are burning at full power, and some are in their final moments. And that's where things get really interesting, because a star's death is just as important as its birth and its life. Now here's where things get crazy. What happens when a star runs out of fuel? Let's go back to the balloon analogy. When the pressure inside drops, the balloon collapses. Same with a star. Once the hydrogen is gone, fusion slows down and gravity starts crushing the core. But instead of just shrinking and disappearing, stars go through this insane transformation. For a star like our sun, this means swelling up into a red giant. Imagine a campfire. When the embers start cooling, you can blow on them to reignite a burst of flame. That's what happens when the core contracts. It gets hot enough to start fusing helium into heavier elements like carbon and oxygen. This process makes the outer layers expand, and suddenly our sun once a calm, warm star becomes a bloated red giant big enough to swallow Mercury, Venus, and maybe even Earth. But eventually, even helium runs out. At that point, gravity finally wins. The fun will shrink down into a white dwarf. This super dense leftover core that's basically the size of the Earth, but with the mass of a star. Over trillions of years, it'll cool and fade into a black dwarf, an invisible, frozen remnant of what was once a brilliant star. Now, if the sun's death sounds dramatic, trust me, it's nothing compared to what happens to massive stars. Instead of becoming a red giant, these monsters turn into supergiants, fusing elements all the way up to iron. And here's the thing, iron is a dead end. You can't squeeze energy out of it like you can hydrogen or helium. So when a star starts making iron, it's basically writing its own death sentence. When fusion stops, gravity doesn't just pull the core inward, it slams it inward. We're talking about a collapse so fast that atoms themselves get crushed. The result? A supernova, one of the most violent explosions in the universe. This blast spreads heavy elements like gold, iron, and uranium across space, seeding new planets, stars, and even life itself. Now, depending on the mass, the core remnant left behind can become a neutron star, where matter is so dense that a teaspoon would weigh billions of tons. Or if it's massive enough, it collapses into a black hole, a point of no return where gravity is so strong that not even light can escape. And just like that, a once massive star becomes a ghost, influencing everything around it, even after death. So what does this tell us? Stars aren't just distant specks in the sky. They're active, evolving, and cycling through patterns that repeat across the universe. Whether it's a small red dwarf burning slow or a massive supergiant exploding in a spectacular supernova, the same underlying principles apply: balance, collapse, transformation, and renewal. It's a cosmic process that's been happening for billions of years, and it's still happening right now. When you look up at the stars, you're not just seeing light, you're seeing time itself. Some of the stars you see tonight could already be dead. Their light's still traveling across space to reach us. And others, they could be forming right now in the vast clouds of dust and gas scattered across the cosmos. If this stuff fascinates you, if you want to explore the deeper mechanics of the universe and how these patterns emerge again and again, then check out my book, The Conscious Dance, Quantum Gravity, Fractals, and the Fabric of Reality, available on Amazon and Kindle. You can also follow me on Facebook at Fractal Consciousness Theory, where we dive deeper into these ideas and have some great discussions. Thanks for watching. Drop a comment below if you've got any questions or thoughts. And as always, stay curious, and I'll see you next time.